Okay, let's look at section 5.1, area and estimating with finite sums. The next couple sections, 5.2, 5.3, 5.4, you can almost think of them as culture, but certainly very necessary background for a fundamental result that we're going to get to. Now, back when we were talking about derivatives, there was a motivating question that helped us decide, and not decide, but helped us motivate what the definition of the derivative was. The motivating question when we were doing derivatives was slope at a point, slope of a tangent line at a point. And that question, we looked at that, and that motivated what was our definition of the derivative. The motivating question that we're working forward from, the motivating question that's going to guide our next several sections of work is areas underneath curves. That I want to eventually, and we're not going to do it this section, but between this section and the next section, I want to find the area underneath this curve on the interval from 1 to 3. Now I want to find eventually the exact area. Now the thing we have to note here is that this is not a common geometric shape. This is a parabola. And we don't have any formulas that tell us about areas under parabolas. So here's our motivating question. What is the exact area of the region? And again, from 1 to 3. So we're looking at this guy right here. What is the area of that region? Got a little sloppy there. First use of whiteout, and it's not working very well. There we go. Okay, and then it says, using common geometric formulas, it is not possible to find the exact area. However, we may estimate the area using rectangles. So that's what we're going to do. We're going to try to come up with an estimation. So it says, using finite approximations, so all that means is a limited number, estimate the area underneath the graph of f of x equals 16 minus x squared between 1 and 3 using a lower sum of two rectangles of equal width. Now all we mean by a lower sum is that the rectangles will meet below the curve. And you'll see what I mean by that as soon as I draw some pictures here. Then of equal width, we're going to let the width of each rectangle be denoted by delta x, and then you can just trust me that delta x is going to be b minus a over n, where n equals the number of rectangles. So there's just a little terminology for us. Go out a little bit so you can see more of one. And I think I'm just going to go on to a new piece of paper here and redraw my picture. So there's 16. There's the parabola 4, 2, 1, 3. Okay, so it said equal width rectangles. We wanted two rectangles. So for our problem, two rectangles. Two rectangles means that n equals 2. So delta x, which is b minus a over n, is going to be 3 minus 1 over 2. And let me put this, two rectangles on the interval 1 to 3. So that tells me that delta x, which is always going to be given by the formula b minus a over n, where a and b are the endpoints of your interval, n is the number of rectangles. Delta x is always b minus a divided by n, so in this case 3 minus 1 divided by 2, or 1. So that's the width of each rectangle. So let's draw in some rectangles. Remember, we're only going from 1 to 3. So here's the base of my first rectangle. It's 1 unit. Then it said a lower sum. And so the rectangle will meet below the curve. That's kind of what we mean by a lower sum. And then my next rectangle has a width of 1. And then it meets below the curve. And so there are my rectangles. And I'm going to label those S1 and S2. So there's my picture. And so we were told to find the area. And so the area will be approximately equal to, squiggly equal sign, approximately equal to, area of S1 plus the area S2. Then showing, every single detail. Why we picked rectangles. Rectangles are easy. Now that is not the only shape mathematicians have used to approximate areas. Trapezoids are also used because trapezoids do have a fairly nice formula for finding the area of a trapezoid. And trapezoids do a little better job as far as getting a better estimate, but rectangles are easier, so we're going to go with rectangles here. Area of S1 would be the height, S1, times the width, S1, and dropping down because I'm running out of room. Height, S2, times width, S2. And so approximately equal to, and let me just write that height 1 instead of height S1. So just H1 stands for height S1. And then we were told each time that the width, each width was delta x. Now, yes, eventually I'm going to replace the delta x with a 1, but I am kind of building to things we're going to see later on. So I just want to use that delta x for now. That remember, delta x stands for the width of the rectangle. That's what we wrote down here. Let the width of each rectangle be denoted by delta x. So the width of S1 is delta x, then plus the height of S2. So H2 instead of writing height S2, and each width is delta x. Now the heights. Right there, there's my height of S1. And that point right there is 2. My x-coordinate is 2. And then how we always get y-coordinates? F of 2. And it's the y-coordinate that is going to give me the height. And so this will be f of 2 delta x, that your y-coordinates, I want that vertical distance right there. Well, vertical distance is measured by that y-coordinate, so my height is f of 2. And similarly, this point right here, the x-coordinate is 3. The y-coordinate would be f of 3, and so the height is f of 3 delta x. And then I could, if I wanted to, put that delta x out, just factor it out to the end. And so now let's do some calculations finally. Recall f of x was 16 minus x squared. And delta x we calculated to be 1. And so this is going to be equal to, or approximately equal to, 16 minus 2 squared plus 16 minus 3 squared. Put the square in the wrong place. Times 1. The parentheses, those inner parentheses weren't necessary, but they aren't hurting anything. And so what do I got? That's 4. That's 12 plus, and that's 16 minus 9, 7. Times 1. And so I get 19. And then because my rectangles were a little too short, this is an under estimate. And there we did our first estimation by just using rectangles. And the reason why rectangles is easy because we know the formula for area of a rectangle, height times width. So this particular guy, lower sum with 2 equal width rectangles, gave us 19. And now we're just going to do this 2 more times. The idea is the same each time. We can just do slightly different things. So we're going to do it again, but this time with an upper sum. So here was a lower sum where the rectangles were a little bit too short. They met below the curve, and we got 19. This time, same question, upper sum, rectangles of equal width. So let's remember delta x equals the width of the rectangle. And delta x is always going to be given by b minus a over n. So in this case, 3 minus 1 over 2, still 1, just like it was before. But now an upper sum. So drawing my rectangles again. And remember, we're on the interval from 1 to 3. So equal width rectangles of 1 unit. So my first rectangle is going to go from 1 to 2. And this time, upper sum, which means the rectangle kind of meets above the x-axis, or not the x-axis, the curve. So there's rectangle 1, I'll call that S1. Then rectangle 2, width 1 unit, so I draw the base first, then draw in the rectangle, upper sum, so basically meets above the curve. It's a little too tall. So S2. Then it's the exact same logic that the area is going to be approximately equal to the area of S1 plus the area of S2. And again, not skipping steps. That's the height, S1, times the width, S1, plus the height, S2, times the width, S2, height times width. And then just going down, instead of writing height S1, I'm just going to write H1. And then each of the widths is delta x. So height 1 delta x plus height 2 delta x. And then the heights. The heights you're going to find that by where the curve meets the rectangle. And so the curve meets in rectangle 1, that height right there is on the left. That point there has an x coordinate of 1. Its y coordinate, I find all y coordinates by just plugging in. The y coordinate is f of 1. So this is going to be f of 1 delta x. Similarly, my second height is right there. There's the height of the second rectangle. 2 is the x coordinate, which makes the y coordinate f of 2. So my second height is f of 2. I can factor out that delta x. And then I can recall that f of x is 16 minus x squared. And delta x equals 1. And on the next video, we will plug those values in. So ending this video, go into the next one.